Thanks for coming. I'm really excited to see you all here, especially when there are so many great workshops going on right now. My name is Vit, and I'm a front-end engineer at a tech startup called Safel. We are based here in downtown Prague, right at the Wenceslas Square, with a beautiful view of the Wenceslas Square on one side and the Prague Castle on the other side. And if you enjoy working with React, please stop by our booth, get a beer, and talk to our engineers. So I'm here today to tell you that the world has changed. That the tools we're using today to work with JavaScript are on the inside fundamentally different than the ones we used only a couple of years ago. And that it is high time we reconsider how we approach refactoring. So traditionally, refactoring has been the domain of integrated development environments. But that has changed. And the world is moving in the direction of using abstract syntax trees and their transformations. We at Safel are also using them for refactoring our code base. And in this talk, I'll try to convince you that these tools are easy to understand and simple to use. And at the end of the talk, you'll be able to start using them in your own projects. We started the development of our product well before the tools like eslint, babel, or webpack became widely popular. Since then, we have grown our code base and team significantly, but we started to feel like we were falling behind the times. We wanted our code checked for simple mistakes like using an undeclared variable or an import that didn't exist. We wanted to use the latest ES6 and ES7 language features to make our code base more maintainable. And we wanted hot reloading for faster development feedback. And we wanted all of this not just in a couple of files. We wanted it in the whole code base. In your projects, you may have similar goals that may be achieved through refactoring. So why not use regular expressions? Imagine a seemingly simple task of validating an email address. When this is what it takes to properly validate an email address, then how can you ever correctly parse a JavaScript program with a custom RegExp? You can't. Instead of using a generic purpose tool like a regular expression, you should consider a tool designed for the job. These programs are called parsers. They are built on top of regular expressions, and their output is something called an abstract syntax tree. So what exactly is an abstract syntax tree? For the purpose of this presentation, the answer is very simple. It is the representation of your program or source code in the form of a data structure. It is created by a program called a parser, and it is the basic building block of many of the tools we're using today. For JavaScript, it's defined in the specification called ES3, which has been derived from the internal representation of a JavaScript program in Mozilla's SpiderMonkey engine used in Firefox. As far as I know, the very first tool that have taken advantage of this solid ground for processing JavaScript programs was eslint. It has strictly separated the phase of parsing from the phase of linting. Parsing is done by a dedicated parser, and the AST it produces is then passed as an input to a linting rule that anyone can write. And this brings us to the central topic of this presentation. So what do I mean by an AST transformation? It is a program that inspects or manipulates another program's AST. And I'm sure you've heard about one of these, but perhaps under a different name. So who has ever heard of an eslint rule? All right, a lot of people. What about a babel plugin? Okay. Webpack loader. Prettier? And what about auto prefixer? So it looks like almost everyone here has heard about one of these. So let's take a closer look at them one by one. What does an eslint rule do? It takes an abstract syntax tree of a JavaScript program and it returns an error message. What does a babel plugin do? It takes an abstract syntax tree of a JavaScript program with some new language features not supported by all browsers, like an arrow function or an optional chaining operator, and it returns another abstract syntax tree where these constructs have been replaced with something the old browsers understand, like a regular function or a ternary operator expression. What about Webpack Loader? What does Webpack Loader do? It takes some kind of file and returns JavaScript. Now, while most loaders defer the AST transformation to Babel, there are some that actually do the transformation on their own. What about Prettier? Prettier takes the AST of a JavaScript program, completely disregards the original formatting, and then formats the AST into source program for a given line width. And what about auto prefixer? It takes the AST of a style sheet, in this case, and adds or removes vendor prefixes depending on the browsers you're targeting, and returns a new AST. All right. But there is one more specifically designed for refactoring that I would like to talk about today. But before we do that, let's take a look at what an AST of a JavaScript program looks like. To do this, we'll use an online tool called AST Explorer. It is similar to CodePen or Code Sandbox, but designed for learning about ASTs. So this is what it looks like. Can everybody see it? All right. So to quickly describe the UI, at the very top there is a menu. You can create a new snippet or save the one you're currently working with. Next to it is a menu where you select the language you'd like to explore. And next to it, you pick a parser. We'll be using the latest Babel parser. On the left side, you enter your source code you'd like to learn about, and on the right-hand side, you see its AST. But as you can see, even for a very simple program, the AST is quite big. So let's start with something very simple, a single variable declaration. Okay, so the tree is a data structure composed of nodes connected in a single direction. And each node is a regular JavaScript object with a type field determining the type of the node. And starting from the root of our tree, we have a file node which contains a program key pointing to a program node, which in turn contains body, which is an array of statements. In our case, it is a single variable declaration. The name of the variable is A, and it is not initialized. So let's initialize it to some random value. Okay. And we see the init field now points to a numeric literal with a value of 42. Now, var is a thing of the past, as everybody knows. We should be using const where possible, or let, if const is not the thing we could use. So let's change it to const. And we see the kind has changed to const. Now we could play a game. You could tell me your favorite language construct, and I will tell you the fancy names of the nodes it generates. But it would get boring rather quickly. So instead, let's ask, how is it useful? Because the tree is a data structure, it's easy to manipulate by a program, unlike the source it comes from. So who here has ever written an eslint rule? Okay, we have a couple people. Most people haven't, so let's create one. I'll go to the transform menu and select the eslint. And AST Explorer has a default snippets for you to learn about each of the transformations. For eslint, it is a rule that complains about the use of template literals. Now, I'm actually quite fond of template literals, but I do not like when people declare multiple variables in a single declaration. So let's put an end to that. Const a equals 42, b equals math.py, c equals math.e. Okay, there are two things you have to know in order to write an eslint rule. The first one is that it is a function that receives a context object that you use to complain. And if you want to complain about something, you do it by calling context.report, passing in the node you're complaining about, and a message to the user. So I will want the user to move the second and third declarations to separate variables to separate declarations. So move this to a separate declaration. The second thing you have to know is that the return value of an eslint rule is a visitor object, and the keys are the types of the nodes you want to inspect, and their values are functions that are called by eslint for the inspection. So I'm not interested in template literals. I'm interested in variable declarators. You can see I have 3 of these. And now eslint is complaining, but it's complaining about every variable. That's not what I wanted. Luckily, it supports something like CSS selectors. So I will use the JSON selector pattern represented by the plus character. I'm sure you're familiar with this from CSS. And now eslint is correctly complaining about the second and third variables. So let's try fixing it to make sure it works. Okay, not complaining. Let's break it again. And it, all right, and it is complaining. All right, this is great. But there's one problem now. Who here enjoys fixing a lot of eslint complaints manually? No one. Oh, there's one person. Congratulations. Well, I personally don't. So maybe you're thinking about the eslint fix option now. Well, while eslint allows us to inspect the tree, it doesn't allow us to change it. The reason for that is that it is not clear how to merge the changes made to the tree back into the source code in a way that when you compare the original file with the result, with the fixed one, that you only see what you changed. So to avoid this problem, eslint gives us functions to access the original source code and to find text in there and replace it. But that's not really what we want. We don't want to manipulate text. We want to manipulate data structures. We want to manipulate the AST. So is there a tool that could allow us to do that could help us here? Yes, there is. And you saw its name already. It's called JS CodeShift. Comes from Facebook. So let's create a new snippet. The default example AST Explorer gives you for JS CodeShift is the one that takes all the identifiers in your original program and reverses them. So tips becomes spit, and so on. So let's try adapting this for our use case. JS Codeshift has a different API than eslint. It doesn't work with visitor objects. Instead, it has a nice collection-based API where you can search for nodes in the tree and manipulate them. So here I want to replace the single variable declaration I have with a set of separate declarations for each of the variables. And I will do it by typing path.node, that's my variable declaration node, dot declaration dot map right, and each of the declarators will turn into a separate variable declaration. Now here I was searching for a node and I was using a capital letter at the beginning. Here I'm creating a new node, so I will use it lowercase 1, and it is a function. It takes two variables. The first one is the kind of the declaration we want, var, const, or let. I want the same one I had in the original source code, so I will type path.node.kind, and the second argument is the list of variables for this declaration. So I only want one, the one I'm mapping over with. So voila. So I just turned a single declaration with multiple variables into multiple declarations with a single variable. So what I will do now is I will take this code mod and I will run it across my whole code base. It will take a couple of seconds. Then I will install the eslint rule that we built before. And from now on, there will never again be multiple variable declarations, multiple variables declared in a single declaration anywhere in our code base. Okay. This is a simple example. So before I switch to my slides, can you think of any other use case for this tool? Right? I'm sure you have something in mind. Okay. The one I showed you was a replacement for eslint fix, which comes quite handy. There are other things that people use this for, like converting var to let and const across the whole code base, not a single file, right? The whole code base. Converting custom IIFE modules to ES6 modules. Converting custom inheritance into ES6 classes. And the thing that maybe you have used yourself if you ever upgraded React or Flow in your project to a new version after a breaking change. That is, you can create upgrade scripts that you provide to our customers so that they can run it on their code base after you make a breaking change in your API. And basically anything else you can achieve through refactoring. All right, I have a couple of references for you if you'd like to learn more. The first two are videos, the second two are GitHub pages. And in case you are from Prague and you'd like to learn more, you can join our ReasonML Prague meetup. At the next meetup, we'll be writing a transpiler for the optional chaining operator for Fastpack, which is a competitor to Webpack, and we'll be doing it in Reason. And to summarize it, what we just talked about, you have a lot of code, you want to refactor it, but you can't do it manually, either because it would take too much time or because the edits would be too complex and you don't trust complex edits to your code done manually. Regular expressions are not fit for the job because they are difficult to get right and hard to maintain. So my message to you is embrace abstract syntax trees and get the job done. Thank you.